The creation of an AI chip begins long before anything physical exists. Engineers first design the architecture using specialized software. They decide how many processing cores the chip will have, how memory will be organized, and how efficiently it can perform mathematical operations used in machine learning. AI chips are optimized for parallel computing, which means they can perform thousands of calculations at the same time. Once the design is finalized, it is converted into an extremely detailed blueprint that describes billions of microscopic transistors. These transistors are the tiny electronic switches that form the basic building blocks of all processors. Modern AI chips can contain tens of billions of these switches packed into a piece of silicon only a few centimeters wide. Manufacturing starts with a material called silicon. Silicon is refined into very pure crystals and sliced into thin circular wafers. Each wafer can hold hundreds of chips. The wafer then goes through a complex process called photolithography. In this process, patterns from the chip design are projected onto the silicon using ultraviolet light. Special machines deposit and remove layers of materials on the wafer to create the transistor structures. This step is repeated many times, building layer after layer of microscopic circuits. Some modern chips use extreme ultraviolet lithography machines made by ASML to achieve extremely fine patterns measured in nanometers. After the circuits are formed, the wafer is tested to identify working chips. The wafer is then cut into individual pieces called dies. Each die becomes a single processor. The next stage is packaging. The chip is mounted onto a substrate, connected with tiny wires or microscopic solder bumps, and enclosed in a protective casing. Packaging also allows the chip to connect to memory, power sources, and other components inside a computer or data center. Finally, the finished chips go through performance and reliability testing. Manufacturers check if the processors operate correctly under different temperatures and workloads. Only chips that meet strict quality standards are shipped to device makers. When installed in servers or computers, these AI chips power tasks such as training machine learning models, running recommendation engines, and supporting applications like speech recognition and computer vision. Although the final processor may look small, producing it requires years of research, extremely precise equipment, and one of the most advanced manufacturing processes in the world.